up, Mom. Like, get over it. It's okay. Suck it up. You'll be fine. Okay. So, couple of things. We were gonna talk about, registration today, but they have us going to a little bit of a training tomorrow, so I wanna see what I hear tomorrow at the training before I talk to y'all. It's kind of like a drop-in training. So once I hear that, I'll talk to you a little bit next week about it. We are finishing up 4-2. I have not told you when chapter 4 is due yet. We have a total of 18 pages. As you can see, probability can be easy, can be hard because of the wording of the problems. The review is going to be your best bet to get you ready for that test. And just because it's in the homework does not mean that it's going to be on the test. Okay? Now, when we had left last time, we had started talking about independent and dependent. And we said, and this actually, I had done this part at the beginning of class last time. I said that independent mean they did not have anything to do with each other. If you're an independent person, if you are an independent woman, you don't need no man. You don't need nothing. You don't need anybody to help you. So independent means rolling a die has nothing to do with flipping a coin. They have nothing to do with each other. Dependent, if you depend on somebody, that means y'all have something to do with each other. So dependent would be like me picking a card, and then the next person, what they get depends on what I chose. So that would be dependent, okay? And we did a couple of examples, and that's kind of where we left off last time. So I have a couple more examples. This one says selecting a king from a deck of cards of 52 playing cards, not replacing it, then selecting a queen. Would that be dependent or independent? Dependent. This would be dependent because you're not replacing it. You're not putting it back. And this would be event A. And this would be event B. So the first thing that happens is somebody picks out a king, they put it in their pocket. And then the next person picks out a queen. So that is dependent because the first person kept it. Okay? The next one says tossing a coin and getting a heads, rolling a six-sided die and getting a six. Dependent or independent? This one is going to be independent. They have no, what you get on that coin has nothing to do with how you roll that die. Those are independent. We want all of these for the test. Driving 85 miles per hour and then getting in a car accident. This one is going to be dependent because the faster you drive, the more likely you are to get in a car accident. Okay, so that one's going to be dependent. And then down here, they wrote their solutions, where the first one is dependent, the next one's independent, and the last one is dependent, which is what we just talked about. And that was just kind of a review from last time. We're still in 4-2. Okay? Now we're going to talk about replacement and not replacement, which is kind of what we were talking about here, putting it back into the deck and not putting it back into the deck. Now, let me put a page up here just to show you. If I had 15 cards and I said 4 were red, what is the probability of getting a red, replacing it, and getting another red? Okay, so we have 2 events going on. My first event is to get a red, look at it, put it back in the deck, shuffle it up, and then my second event is to get another red. So I want to know the probability of getting a red and then the probability of getting another red. So probability is what makes me happy over total, and then what makes me happy over total again. So what makes me happy in the first one? 4/15. Now, when I pull that first red out and I look at it and say, hey, I got red, I replace it. So when I go to draw again, how many cards do I have? I still have 15, right? Because I put it back. And how many reds do I have?
4.
Now, when you have two events, two simple events, we just multiply them together. Okay? Probability of the first event times the probability of the second event. So my answer, we can do one of two ways. Not like that. We can do one of two things. We can either say 4/15 times 4/15, or we can say 4/15 to the second. Are we good with that one? Okay. Now, if I take the same problem undo, copy, and paste. Do not replace. Same problem, but this time I am not replacing the card. So I pick out my red card and I put it in my pocket. So this time, we're still doing two events. We have the probability of the red and the probability of the red. The only difference now is when I go pick out the first card, what is the probability of that happening? 4 divided by 15. But I put the card in my pocket, so when you go pick it out, how many cards are there to choose from? 14, and how many reds are there to choose from? 3. Because I kept a red. Because the probability of getting a red is 4, and because I have a red, I put it in my pocket. So there's now 3 reds to choose from, and there's 14 total to choose from.
How do we know it if I pick up a red from the first one?
Because what makes me happy is the red, so I know that I got a red. We good? So if you do not replace, then your number is going to get smaller. But if you do replace, the stack is going to be the same because you're putting it back in. So for this one, it's going to be 4/15 times 3/15. Thank you. 4/15 times 3/14. So here the probability was about 7.1%. Now my probability is a little bit less because I took that card out. The next person has one less card to choose from. See the difference? So we're going to be doing with replacement and without replacement. So replacement means putting it back in. And then without replacement means that we're going to keep it. Okay, so that's what we're going to be doing now. Still basically the same thing, except now we're throwing like another little twist in it. So that is what this is talking about. It says replacement means putting back in. Without replacement means keeping it. Now, replacement is an independent, which means nothing to do with each other. Without replacement is a dependent, which means the first pick depends on the second pick. Let me write it the other way. The second pick depends on the first pick. So the reason the first one, if I put the card back in, if Amani picks, sees her card and puts it back in, And then Naya picks, those answers have nothing to do with each other because you had 15 cards, you had 15 cards. So those are independent. They both have 15 cards to choose from. If I keep the card, if Amani takes hers out, keeps it, puts it in her thing, then what she keeps depends on the leftovers. See the difference? Alright, so we're going back to McDonald's, Burger King, Wendy's, and Taco Bell, and whether the orders are accurate or not accurate. And this time we are selecting 2 orders. Find the probability that both orders are not accurate. And I'm going to make it bigger. Let me move this down a little bit, and 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 this down a little bit. All right, can I just copy that? Yes, I can. Clone. Hold on just a second. I'm going to move all of this to the next page to give me a little more room. I can't do that again, so I'm gonna do this. All right, so the first question says, assume that selections are made with replacement. With replacement means we're putting back the order, which sounds kind of gross, but we're putting it back in. And we are selecting 2 orders. So we have the probability of the A and the probability of the B. We're doing 2 different things. Order 1 and order 2. These down here. And we're going to multiply them together. And because it's probability, it's what makes me happy over total. So the first thing I need to do is figure out what? How many total orders? So how am I going to get the total orders? We're going to add all this stuff up. Add up all of those and then total them, and this is going to give me my total. So I'm going to come across and up and down, and however I want to do it, it doesn't matter which way I go. So when putting all of those numbers together, the total of everything is going to be 1118. Now, we are putting back, we are replacing. So what is this going to be? The same thing, because we're putting it back in. We didn't keep it. Had we kept it, this would have been 1117. Y'all with me? So because we're replacing it, this is still going to be 1118. Now, we want to know the probability that they are not accurate. So what we're looking on the top is what makes me happy. What makes me happy is that they're not accurate. So how am I going to get those? Add up all of those. So when I come over here, it's going to be the 33, 54, 31, and 13. That's going to give me 131. Now, what is the top of the second one going to be?
131.
131 as well. If I said not replacement, what would that second fraction be? 130 over 1117. Okay? Now, to get my probability, I am going to multiply those 2 together. So, if I come down here, it is going to be clear, parentheses, 131 over 1118 131 over 1118, or we could have done it to the second power, just to show you. So my answer is going to be 0.0137 if they want a decimal, or 1.37 if they want a percent. And then we can math enter if they want a decimal. So the probability that I drive up to any of these and get two orders that are not accurate, assuming that I put the orders back in, is going to be a 1.37% chance. Now, we're going to do the same thing, but this time we're going to do it without replacement, which is what we just did. So, probability of the first one is going to be not accurate over total. So we said that the total of adding them all up was 1118. And we said that when we add up the not accurates, it was 131. So the probability of the first person driving up is going to be 131 over 1118. But because we are not replacing, it's going to be 130 over 1117. Because the first person took their order and went away and with their wrong order and they didn't bring it back. So to get that one, 131 over 1118 times 130 over 1117. There's my answer to that one. 0.0136 or 1.36%. Yay? So keeping up with, do you put it in or do you leave it out? All right, now we're talking about cards again. Find the probability if you have a standard deck of 52 cards. The first card is not replaced before the second card is selected. Find the probability of selecting a heart, then selecting a club. Do you want to try this one or do you want to do it together? Together, okay. So, we are doing two events. It says we're selecting two cards. So we're going to pick our first card, then we're going to pick our second card, then we're going to multiply. And because it says probability, that means what makes me happy out of total. So the first card that we're picking is a heart. So we want to know the probability of a heart. And then my second card that we're picking is a club. Which one is the club? The one that looks like cauliflower? Okay? And we are not replacing, so we are not putting it back into the deck. So, probability means what makes me happy over total. So, for my first one, how many total cards are there sitting when my first person picks?
52.
52. And how many hearts are there for that first person to pick?
13.
So my first fraction is going to be that there are 13 hearts out of 52. 13 hearts out of 52 cards. Yay? Simone decides she's going to pick a heart. So that card is in her pocket. I don't care which one, she just picked a heart. We did not replace it. So how many cards are left for Luke to pick from?
51.
51. And how many clubs?
13.
How many clubs?
13.
How many clubs? 13. Just making sure.
I was about to
Now, had we done a heart and another heart, it would have been 13 and 12. Had we done a heart and another heart. But because Simone had a heart and we're going for a club, Simone's heart did not affect our clubs. So that's why the top number did not go down. But had it been a heart and another heart, it would have been 13 and 12. That's why the bottom number went down and the top number didn't. So when I go to my calculator, it is going to be 13 over 52 times 13 over 51. There's my answer. And it's so easy when I do it. Yay? They wrote it wrong on there. Yeah, they did a red card. They did a red card in a club. They didn't do a heart in a club. Yeah. They have .127. They did a red card in a club. I'll do that one so I can show you. Let's do that one. I found their mistake. No. Yeah, I have somebody else helping me with notes, and I'm like, you totally screwed up. Okay. It says you're gonna choose 2 cards, no replacement. First card is red. Second card is a heart. Choose 2 cards. First card's red, second card's a heart, no replacement. Y'all wanna try it? Yeah. Go ahead. Yes. Yeah, this one's wrong. Yeah, that should be 13 over 52 and 13 over 51. Yeah. Choose 2 cards, no replacement. First card's red, second card's a heart. All right, so we have 2 events, because it says choose 2 cards. So the probability of the first event is that it's red. The probability of the second event is that it's a heart. So my first event is going to be all of this. So what makes me happy is that it's red. How many reds are there? 26 out of 52. So I just randomly pick a red card, a red card, and I put it in my pocket. Now, what's the probability that it's a heart?
12 over.
Yay? And then that is gonna give me
1176.
0.1176. We good? Cool? All right, let you try one more. Coin is tossed, a die is rolled. Find the probability of tossing a tail and rolling a number greater than 2. So you still have 2 events. You're going to do the first event, you're going to do the second event. Find the probability of each and multiply.
A die has 6, right?
A die is 6 sides. It's a regular 6-sided die.
If it doesn't say that's replaced, should we just assume that's not being replaced?
Are these dependent or independent?
Oh, no.
I love you. Alright, Haley is here, Stacia is here, Ann is absent, Brittany Brown is here, Adrian is not, Kiki is here, MJ's here, Amani's here, Billy's here, Josh is here, Kristen is here, Naya is here, Amy is here, Jabria is here, Luke is here, Caitlin is here, Ashton is here, Simone is here, Mariah is here, Kate is here, and Kelsey is here. Alright, so my first event is the coin, and I want to get a tail. My second event is the die, and I want to get a number that's bigger than 2. Okay, so on my die I have a 1, 2, 3, 4, 5, and 6. On my coin I have a heads and I have a tails. So probability is what makes me happy over total. So for the first one, how many sides are there? How many total sides?
2.
And how many make me happy? 1. Now, the first event has nothing to do with that second event. So what I get on that coin has nothing to do with the die. We want a number that is greater than 2. So 3, 4, or 5. 3, 4, 5, or 6. So there are 4 sides that make me happy out of a total of 6. So we're going to do 1/2 times 4, 6. You really don't need to reduce it because your calculator will do it for you. So it's going to be 1/2 times 4, 6. And then math, enter, whether you want a fraction or whether you want a decimal. So this would be my fraction, that would be my decimal, that would be my fraction, and 33.3 would be my percent. Cool?
On our test, when we have, I know it has a picture of the cards, but if it asks questions about dice, I don't really know what type of dice. I be wanting to say 7. Will it tell us?
Usually when it says die, it's going to be a 6-sided die. Unless it says 12-sided die or 10-sided die, it's understood to be a 6-sided die.
Okay.
Yep. And think about your calculator or your phone. There's a top and a bottom, a front, on your calculator or on your phone or whatever. There's a top and a bottom. There's a front and a back, and there's a left and a right. So this is just like an I. So you've got 1, 2, 3, 4, 5, 6.
Okay.
So it's just like this. Yep. All right, let's look at another one. 1,000 people were asked about Hollywood celebrities being good role models. 200 of the 1,000 said that